Okay, you are live. Thank you, everybody, for joining us for today's Linux Foundation Decentralized Trust virtual meetup. We're going to be talking about programming, chain code, and Rust for Hyperledger Fabric. And with that, I will hand it off to Arne.
All right, thanks. So I'm Arne. I'm developing the Fabric Rust SDK. Start sharing my screen so I can show the repo. Yes, here you go. So the link to the repo has been already posted into the chat. We're going to talk about where we're currently staying, where we currently are in the development of the Fabric SDK Rust. Last time we've talked about about interacting with the network, and now the SDK extended to programming chain code for the Hyperledger Fabric network. Don't get confused. In the LF Decentralized Trust Labs GitHub is also the Fabric chain code Rust repo. There's currently no ongoing development in this repo. There is many logic which is shared between the chain code part and the gateway part, the part interacting with the network. And currently, both of these features are merged in one project. So that's just it's not that much work than being split into two repos. The repo, so the library is available on crates.io. I've made an release on it. I can post the repo in the chat here. So it is officially available. Just to put it into your cargo.toml Rust project file. And then you can, are you ready to start the project or start programming for the Hyperledger Fabric network? The documentation, you can get it from the repo. Keep in mind there are two parts of this library, the client part and the chain code part. Currently, both of them are in one package. In the future, this will be changed. There is an issue going on for that to get these both separated so that the library is being minimized. And yeah, so today we talk about the chain code part. We're going to talk about the first code examples we are having, talking about the structure, how it's being built, how you can deploy it by yourself, how the communication with the peer network is being handled by the library or is generally being handled by the peer. So you get an overview how this works and how you can contribute to the project, and what features are missing, what is being implemented right now. And yeah. As you can see, the documentation, if you just click on the chain code part here, you get a bright overview how to set everything up. Keep in mind, and I've said it before with the gateway part of the library, that this is still in heavy development. There are many bugs, many features missing. So do not use it for production. Just a disclaimer, little one. I'll be happy if enough people contribute to the project that we can integrate it into the official sets of libraries available out there. I think Rust has a strong standing in the community, and many people are asking for it. So yeah, there is a repo on my GitHub page. Let's see, I have it. Yeah, here. So there exists a repo with Fabric samples. This is a fork of it. I can post it in here. I've posted some one code example there. So this repo is usually being used to show code examples in different languages. So we have some asset transfer examples, some auction examples and stuff like that. I've made a fork of it to provide one example written in Rust, so people can look into it, how it's being programmed. In this case, the asset transfer basic has been implemented in Rust. So you can see here we've got a Chaincode Rust folder in it. And in here we've got the code to for the example. And as you can see here, we've got so many features already from the Chaincode part that you can actually implement this this Chaincode in Rust. This is, of course, not much. Basic features like writing and reading to the ledger is available. Of course, executing functions, defining functions, and stuff like that. But features like putting in private data, for example, is not available. There's actually a list of features that are implemented for different libraries somewhere. I couldn't tell. I was looking for it. I couldn't tell where it went. But there is a list for the Go library, for the Java library, for the JavaScript library. What has been implemented in those libraries. Of course, Go library has the most features, but the other one are in pretty good standing too. And there you can look up what needs to be implemented to have a full feature set. So currently there's just like only the basics for the Rust part. Yes. Let's see the. Are we gonna? We can just like going through the document. So as I said, the Fabric SDK can just be used in the cargo.toml. Just insert it, and you're good to go. Currently, this documentation was not yet in the didn't include the crates.io release. But if you look into the samples, you can see here that the Fabric SDK is just defined normally through the version number. So I need to write me to do to fix this in one moment, so that this documentation is, of course, always up to date. And yeah, there are some pre-requirements before you can start to actually program the Chaincode for the Hyperledger Fabric. Especially because the peer doesn't understand Rust code, especially doesn't understand, doesn't know what to do with it, how to build it. So there's currently a workaround for that. You have to define your own builder. You can find it here. There is an external. I have to look for it. There is an external builder defined in the Fabric SDK. Let me look at this. So as you can see in the root of the project, there's a builder/bin folder. And in there, you have 3 files which are needed to define an external builder. And you need to include these files in your peer config file as an external builder. And if you're running on Docker, of course, you have to add those files as a volume, so the peer is able to read from it. And what these builder are doing is actually pretty simple. It just takes the binary and execute it. Not more, not less. So the other builders, for example, for Go or for Java, actually get the source code and then build the project and then deploy it. But we do not have one for Rust yet. So the external builder we have here just executes the binary, which is the simplest form you can do. Of course, you can have the solution that it just runs the cargo build command or something like that. But sadly, the Docker container or the Docker image from the Hyperledger Fabric peer node doesn't have cargo included, of course. And to keep it as simple as possible, this just takes a binary, since it doesn't need external software to get it running. Yeah. So because of that, the project needs to be configured. For example, in the project configs, you have to have a static name, so Chaincode is being expected. Of course, if you look into the custom builder, if you look into it, it's just like a really, really simple script. You can, of course, edit if you want to, but if you go by the standards, you will probably have less problems. And also, what you have to do is to always build it with static libraries. So another problem is that you, since you're in this Docker environment or like in this node environment where you are not able to expect the libraries being installed or maybe different versions of it, you have to tell Cargo to use static libraries. This will limit some usage for libraries, since some libraries do not like being compiled statically. But most of the libraries do have some features which make this possible. And of course, as you can see, we've got a static target here too. So it's in this case, it's compiled for the for a Linux operation system. The external builder I've provided is only running this type of, or not this type, but one type of architecture. This is something which has to be implemented for the peer. There is an ongoing discussions for binary executables. So this builder you see here is not really usable for the production, but there's an ongoing discussion to be able to execute binaries where also different architectures are being supported, for example. Yeah, and because of the naming and stuff like that, you have to define the bin and where the main source file is. Okay, now to the interesting part. We can define some functions via the transaction derive. This does some handling in the background to make this callable. By providing this transaction derive, every parameter you see here has to be serializable or deserializable from server.json. Other than that, there are no real limitations. Of course, you have a context part here, just like in the Java library. this whole thing is actually oriented by the Java library. So I keep the Java library as example and orientate myself on it. So yeah, so this is the context. The context actually gives context to the ledger, for example. So you can here you can see that the context is actually requesting a state from the ledger, and then deserialize it and returns it as the struct, which is actually being deserialized again in the background. But we'll come to that. So this is how you define a basic function. To get it actually being recognized as function, you have to register it in the main function. So we do an initialization, and then we say dot register, and then the contract name. So instead of it's, for example, the Java library having a class which defines the name of the contract, you define it here by yourself, and then you get put in there the list of the functions which are included in this contract. This implements the contract APIs, I think is it called. So Hyperledger Fabric is able to include in one chain code several contracts which have different names. So if you call it a chain code, you can define a contract in that chain code with a name, which is this name especially, where you want to call the function. Yeah, and you can like chain it to register every function you have there. And that's actually it from the programming standpoint. Of course, I can increase a bit the fonts here. There you go. And now we're coming to the one more configuration. Yes. So the package of the chaincode package you actually create to deploy the chaincode requires metadata.json. Here we have probably many of you already know this, the people who already programmed some chaincode in other languages. Here we have the difference that we define the type as binary, which is being picked up by the custom builder, and of course the label. As I said, this requires the external builder, which I've talked about before. Hopefully this will be soon start of the standard peer software, so that these type of implementations are being much easier to adapt for other people. Yeah. So after defining our metadata.json, we are off to go to compile and put everything into the package. So I've provided a small script I'm using for myself to just pack everything together. It's pretty simple. This just like builds up the architecture so that the peer understands how to handle this chaincode. So we can see that's actually it. We can see a bit in practice, not just in theory. So this is my fork of the Fabric samples repo. In here, I configured the peer to use an external builder. This is actually not in the repo, unfortunately, but it is. Yeah, I should maybe put it online. I look forward after that to put it online so that you can just like copy it if you want to. But as you can see here in the core.yaml file, there's the external builder defined. As you can see, this is just like the internal path of the Docker image. We've called it I just called it cargo. It's not actually the cargo, it's just like the binary executable behind that. But this is just like the placeholder for hopefully in the future the cargo builder for the peer nodes from Hyperledger Fabric. And in the Docker compose file, we've defined the custom config. As you can see here, this is actually another config than this one. I've defined it somewhere else again. And as you can see here, there is the path to the external builder, which is just have to recap. This is just this builder / bin you can you see here, right? So these are just like these three files. So with that, we can start the network. While this network starts, we can package the example. So we're just going to package this example or asset basic transfer example. As you can see, I'm in the project of this example. I've put online the script I've showed you before in documentation. So I'll just will execute this. Of course, you can like copy this in your own project and use it by yourself, or in your own like deployment pipelines, or as you like. And after that, we move this, to the destination where we need to. I move it to the test network folder where the test network files are. So I've started the network now, and now we're going to deploy the Chaincode. I also prepared a script for that because this is actually quite we need to execute some codes. You find all these codes, like these commands, online in the official documentation for the Hyperledger Fabric. I've just put it like in a script, so we do save some time for that. So we deploy these on our test network. And it is installed. The basic transfer is deployed on our network. And now what we can do is invoke this script. So we have like the basic asset transfer functions. So what we're having are, let's have a look inside. So we have a create asset function, asset exists, read asset, update asset, delete, transfer, and get all assets. This is like analog to the other basic examples. As you can see, the functions are defined here with the derive transaction macro. And then, for example, here the create asset. And now we can invoke those. And as always, I have a little script ready for this. So you can see it running. So here we created an asset with fish1 as asset ID and color orange. The second invoke you can see here. This is the read asset function call, where you can see that it actually saved the asset on the ledger and called it again. The third call is delete asset, so it does delete the asset again on the ledger. And here on the fourth call, you can see that we are trying to read the asset fish1 again. And you can see that this actually threw an error because we've deleted the asset before, but just like as you can see how it looks like running into an error looks like. So yeah, these were now the code examples, how you can code some chain code for yourself and how to set the network up to actually understand the chain code. Any questions so far at this point? Because now we will move to we're going a bit deeper into the library. We're going to talk about how the communication is going on behind it a bit. So we're going a bit technical for those people who are interested in. So we can talk about contributing and maybe taking part to this library. So any questions at this point? Is there any comparison in performance between Rust and Go? Yeah, this is a great question. Both are, how do you say it? Both are binaries. So both of these languages produce binaries, and both of these languages are actually pretty efficient. This is like a fundamental question about what's more effective in terms of, yes, maybe Java or JavaScript more faster. But both of them are producing like machine code, and this one's really pretty efficient on the CPU. So I think you won't recognize huge difference between them. The only difference, of course, behind it is the implementation. So how it's being implemented, more like from the structure perspective, right? So if the Go part is significant faster than the Rust part, for example, it's not because the language is the Go language is made more faster. It's just because the implementation is way better, you know. As I could say, the implementation for the Chaincode I've wrote until this point is pretty straightforward. So there's not going on. There's not a lot going on there. So I think if you compare them, they're probably nearly identical from the performance. Of course, this is way more buggier, probably. I'll go into it, what bugs are known and what has to be done and stuff like that. Okay, any more questions? Okay, so then we're going to the more technical part of it. So how this whole thing kind of works in the background, how the communication is going on. I've got draw.io here. So I'll just first of all, I just try to paint the picture how actually everything is communicating with each other. So from the caller we've got on the left, from the to the let's see, network. Let's see, we have nice graph for that. Yeah, that's good enough. And then to the chain code on the right. So okay. So the general architecture, or how would I say, the general communication is always over gRPC. So I think gRPC is most of you a known protocol. So if we try to talk to the peer, so this is the peer node. This is happening by gRPC. So in the gateway implementation of the Fabric SDK is actually a gRPC channel is being opened to the peer, and then functions in the peer are being called. For example, like the function to propose a transaction. So like for example, the actor in this case, if he wants to call something from the chain code, it prepares a transaction, makes a proposal, signs the proposal, and then sends it to the peer. The peer distributes this transaction to the network, signs their results, actually sending it back to the actor, and then the actor says, okay, I want to actually publish this transaction now to the network, and then actually submits it again. So between the actor and peer already there's a lot of going on, but the whole communication is going through gRPC, and in the background, so in the chain code, this is all also done by gRPC. So what happens is that if you deploy a chain code, this chain code is being executed as a normal program. So if we look back into the source code, let's see. No, this is it. Oh no, this is the source code. Yes, of course, we don't want the source code. We want to have the sample here. As you can see, this is like a plain main function which is being executed. And if you look into the builder I've defined here, the one, this is like a pure bash execute command. So this only starts the chain code as plain program. I'm not even actually sure if this is being run in the Docker container. I think currently not. This is just plain being started. And what the chain code is then supposed to do is that it registers itself to the peer. So the peer is calling the chain code. The chain code is building up a connection to the peer via gRPC and says, hey, here I am. I'm here and I'm ready to I'm ready to execute some functions. While doing that, the peer is actually providing some certificate files. So if we look back to the external builder, we have some parameters that are being provided to the chain code. So in this case, we have, hold on, this is not the one I'm looking for. This is the detection. Okay, you can see it here. So the peer actually provides an chaincode.json file in which the whole metadata is being saved. For example, like the certificate and in which organization runs the peer. And the certificate, for example, is being used to authenticate it itself, so that not any chain code just can say, "Hi, here I am," but only the one which is actually being called from the peer, right? So after that, the chain code is saying, "Hello, here I am." The peer says, "Great. I know you're there. I know you've registered successfully," and then says, "You're good to go." And then as soon as the actor is calling a function in the chain code, the peer is executing, or not executing, but sends a message through the gRPC channel to the chain code, and then the chain code has to pass this this message and then answer it accordingly. Okay, so this is how the communication is going on. Since this is a gRPC, this is a gRPC protocol standard. The project, let's see, actually does, where is it? Yeah, has actually Fabric proto files in the repo. So the proto files are there to tell what functions are available from the gRPC server. So in this case, this Fabric protos repo defines the functions we can call on the peer, right? From them, you can generate Rust code, which is like analog to the definitions in the Fabric protos. And then you can like call the gRPC functions natively if you want. So if we look into the repo, you can see here that there's like a Fabric folder with this automatically generated code. Here you can see, for example, let's see, here's an endorse request to the network, which is just a struct, but it tells you how to how these messages are built. We have some identities here which are serialized, for example. Let's see if I find chain codes message. No, there's not. Protos probably here. Yeah, so you can here, for example, find the actual struct for the chaincode call. So this chaincode message, if the callee tries to execute a function in the chaincode, the peer will send a chaincode message to the chaincode. So if you listen to a gRPC channel, you actually get a struct like this. So just for the as an example, what you get from these Fabric proto files. Okay, we have, let's see where we continue. So I'm trying to keep this as simple as possible, but sadly, this whole topic is, of course, not that trivial. So what I'm trying to do is now to just explain some general parts of the library. So if you want to contribute to the code, that you have like a general understanding what to find where. Of course, if you have any questions regarding the implementation or what to do or stuff like that, of course, you can always open an issue. You can always contact me. I'm really happy to help people and to get involved into this. There are, even if this this whole thing is a bit complex, the problems, or how should I say it, the things which have to be implemented are not that complex, since like the general struct is already there, like the signing of the messages, building the connection and stuff like that is already everything here. But just like small things, or like not every problem is of course a small thing, but most of the things are not that huge to implement. So don't get scared if you do not understand everything directly, but still I'm trying to introduce a bit about the whole thing. Okay. So let's see where we start. I think I start with the derives, because probably this is like the most important thing to look into to understand what's happening. So in the Fabric SDK Chaincode initialize function, as you see here, there is the if you call this function, the Chaincode is registering itself to the peer. Nothing more actually happens. Oh, sorry, it happens actually down here. The registration, register, yeah, happens down here. Now I lost like the red line. Yeah, so the peer actually doesn't know anything from the functions. The only thing which happens here is that it says it's getting the label. So for example, the basic asset transfer example is just called basic. So you know that it says here on the basic Chaincode. So if you call the Chaincode, it knows where to route. But for example, the functions you register here are not being sent to the peer. This is all like stuff the Chaincode has to do. Yeah. But anyway, the transaction derives, you see here, these ones. The code for that you can find in the Fabric SDK derives folder. What it actually does is, in short form, it generates a struct which is has the same name as the function, but just like an uppercase. And the struct is implementing callable, so that if you run this this part here, the array, the functions derives array, that actually in the background, not the function itself is being given to the register function, but the struct behind it. And the struct implements callable, and the struct holds the function which is being then called if a Chaincode message goes into the Chaincode via the gRPC connection. So if you look into the initialize function, let's see if we have it here. We have the run here, then the handler. Hold on, initialize. Let's see, where is it? Where is it? This in the mod, of course. Yeah. The initialize, what it does is getting the metadata from the external builder, and then prepares like the whole configuration stuff, and then provides a launcher. The launcher then receives the register functions, where you can see here, this is an array of the callables I've just mentioned before, which fills this hash map with the definitions of the functions. And as soon as you execute the launch function, the message handler is being called and being run. So the message handler, this is actually analog to the Java implementation of that. That kind of analog. The message handler then sends the register message. Let's see if I can find it here. No. Let's see, message handler run. This is the message builder. Here, the message handler. So as you can see, as soon as you create the message handler, you see the register function being sent to the peer. And at this point, the peer knows, okay, I'm ready to, the Chaincode is ready to receive some messages, right? This is being how should I say it? Anyway, so the register, as soon as the register message is being sent, there is an ongoing gRPC channel between the peer and the Chaincode, and this connection stays as long as the Chaincode is running. So here we have in this run function from the handler, you can see that there is, let's see. There's a loop where it tries to, this is the gRPC connection, where it tries to receive the next message. And this, depending on which message it gets, it reacts to it. So we see here, for example, the Chaincode input, where we get the inputs of the Chaincode message, split it into the arguments the callee provide, and the contract function it called, and as well as the contract name, if a contract name is being provided. And as soon as it got the arguments from the call, it is able to execute the function in the which has been registered before in the struct. So here you can see that the contract is trying to get the function with the provided function name. If it's not available, of course, it says either the contract is not found or the function is not found. But if it finds a function, it calls it and then returns here as a response, returns its result. So this is just the plain implement, like the plain struct or the plain implementation of the whole thing. Now, while this function is being called, as we may seen in the example here, we are able to execute statements from the context. So we have a context where we can put stuff into the ledger. And this context is being provided for the function callee. As you can see, it's always a part of the method head so that you can like run these functions. You can find these in the context file here. These ledger interactions like getState string, getState by range. And what it does in the background is that if, for example, if I'm requesting a state from the chaincode, the chaincode is doing another gRPC call to the peer to get the state. Right. So if we look into our diagram here, so what we actually get is let's do this a bit more detailed. This says this does a function call on chaincode xy. Let's see if we can put it. Yeah, so that you actually can see it. What the chaincode gets is a chaincode message, right, with the provided details. So contract x, function y, and the args. And then the peer, of course, still has its connection to the chaincode. So if a chaincode is requesting some state, because, like, for example, if this calls to save an asset, for example, wants to register save an asset in the basic asset example, this function save asset is being called in the chaincode, and the chaincode calls the peer to write gRPC to save the asset. So I think the name is put asset for that, for the function name. This function, you are able to find this function in the proto files, like these generated files here. So we have, if you look into the context in the put state function, we can see that we build a message from type put state with a payload and send this to the peer, right? So this chaincode calls put asset to the peer, and then the peer answers with, in this case, probably OK. And then after the function call completed, we can send back a chaincode result, which is then sent back to the callee, right? So let's let's see. Come on, move. Yes. Okay, so this is how the communication is going on. I see that we are slowly running out of time. So I hope that you kind of got a small insight how the communication is being handled inside the Chaincode. If you want to contribute to the code or have any more questions, stuff like that, in the repo, let's see, you can find under the issues tab, there are some issues listed. Let's see if we find something. Yeah, so they're like basic stuff. We don't have test suits, for example, yet. Or most of the context functions are not available there. As you have seen, for example, here down here, get creator is unimplemented. So this just will throw an error. Yeah, many things are not implemented yet. You can find a list of things which have to be implemented here. So if you want to contribute, you can like pick something up there and just say, here, I'm working on it, to get, the first steps into the code. When I'm personally implementing things for the library, I always look for the Java implementation for it. Often you already find solutions. Someone already made thoughts about it. Often you just have to like look how they've done it and then do it in Rust. Do it in Rust. Often actually more hard than you expect. Especially because there's no real documentation on how to do it, all this whole stuff, right? So as I said, there's like a list of features which is available on the Go library and the Java library and stuff like that. So can of course look into it and may see that many things are missing for the library here. And this list, of course, here is not complete. There are many, many more things to do. But if you like need orientation, what to do, you can always find it here. And yeah, any more questions until this point? I still think about what might be missing. So of course, how this whole thing is being built, this is like just many parts I didn't say anything about it, or like just gone roughly over it. But I hopefully gave you like a first insight on how this all works together. I have one more thing maybe. So the gateway part, so the interacting with the network part, you find it under the gateway folder. And of course, the Chaincode features, you find it under the Chaincode folder in the library. There will be soon a feature where either you activate the Chaincode feature or either activate the gateway feature. Currently, both of them are always being compiled. Of course, this is to do, you can find here. here, add feature for client and Chaincode. But yeah. Okay, I see no more questions. Thank you for listening, everyone. I hope you had fun. And hopefully you've got a bit of a better understanding, especially around the overall communication between chaincodes and peer. For myself, it was quite hard to actually figure out, let's see where I can find here, how actually this everything is running. So for me personally, reverse engineering this whole communication and like signing the transactions and stuff like this was really hard. But yeah, we now have a good foundation on building this library. Only some features, many features are missing, but from there we have a good start to create something great. Thanks.
Great. Thanks, everyone. I'll send around a link to the repo and the recording and the Discord channel to everybody so you have those resources after the event. All right. Thanks, everyone.